Hi there, CTM students. Welcome to the lesson for 13.4. You can find it on pages 767 to 778. And we're going to be talking about these four types of statistical graphs: circle graphs, histograms, frequency polygons, and stem and leaf displays. And as always, make sure you're using those extra examples in the book to help you out. We're going to do 3 examples here together, and there's 5 more, I believe it is, in the book. 6 more, actually. Correct that. So 6 more. Alright, let's start off with a circle graph. What is that? You probably know already, but we're going to talk about how to construct one, and not only that, but how to construct a really nice one, an accurate one that is totally accurate. So construct a circle graph, not one where we're just estimating what it should look like, but one where we actually bust out the protractors. Bust out a protractor to do this carefully. I'm not going to recommend, I am going to recommend actually, but I'm not going to require that you use that here on the notes. But later, if you're one of my students, a very good chance that I will make you do one very accurately using the appropriate tools, protractors, compasses, etc., to be able to show me that you know how to make a really nice one. So construct a circle graph representing the following. We're going to have some data in this table here. This is going to be the number of sports played. I'm going to say I pulled a class of 40 students. Pretty big class there, but 40 students. And this is the number of sports they played in 1 year. So number of sports played in 1 school year, I'm saying. And over here, the number of students. Excuse me. So over here, we had some students that weren't playing any sports. We had some that were playing 1, some doing 2, and some playing a sport all 3 seasons. And then we had, this is what I pretended at least to get as survey results. So 18 that didn't play any sports. We had 7 that played 1 sport. We had 10 that were 2 sport athletes, and 5 that happened to play 3 sports. Over here, my personal favorite 3 sports to play, I would say, would be basketball number 1, ultimate frisbee number 2, and football number 3. So time for a solution here. How are we going to draw a circle graph representing this? How are we going to take this and make that into a circle graph, sometimes called a pie chart as well? So first what we need to do is we need to figure out what part of the total each one of these represents. This is my frequency over here, and this is the data in question, the number of sports in question. So first what we need to do, first determine the, sort of saying the size, but in other words, the central angle. That's, I maybe should have even put that in our vocabulary, but I didn't put that in there. Back there, we need to know what a central angle is. That's something, a term from geometry actually. So find the size or central angle for each part of the circle graph. And so I'm going to make a table here. And I'm asking you to do the same right now. So I want you, not using a different color yet. We are going to need those at some point. So pretty long one. It's going to have 4 columns. You can do that here, that here. And these last 2 should be a little bit bigger. I'm going to make them a little bit bigger here. And then here I'm going to put the number of sports played. I'll use the symbol for number of sports played. We'll go in this first column. Over here, the number of students. So that's just this one and this one. I'm going to copy those down again down here, number of students. And then this is going to be the percent of the total. And then finally, the central angle is going to go right here. What is that measurement for each one of these? So number of sports played, we had 0, 1, 2, and 3. You have blue lines on your paper, so you don't need to draw these, but this is just to make the notes as clear as I can. I'm doing this yellow lines. Come on, yellow. There you go. There you go. All right. All right, and we've got back in black here, we've got 18, we've got 7, we've got 10, and we've got 5 students right there. So what percent of the total is this? Well, the total number of students, we could add that up pretty easily, I hope. This would be 25, this would be 35, and 40. So this is 18 out of 40. That would make it a decimal, so I would multiply that by 100 per cent. Remember, 100 cents in a dollar, good way to think of it. Percent, multiply it by 100, you'd have a percent of, I put this into a calculator already, and I got 45%. All right, this would be 0.05, or not 0.05, 0.45, and then multiply that times 100 would be 45%. 7 over 40 times 100 ends up being 17.5%. This is not a rounded decimal. This is actually the exact value. Sometimes, though, you may find you have to round some decimals off. This one, we've got 10 over 40. That's 1 over 4 reduced, which is 1/4 or 25%. And then finally, 5 over 40. That's going to be half as much as 10 over 40. So we can just basically cut 25% in half and have 12.5%. And then the central angle. How many degrees are there in a circle? Think of that. How many degrees in a circle? There's 360 degrees. So we're going to take each one of these percent values. What's 45% of 360? What's 17.5% of 360? And so on. So I can take 0.45 and multiply it by 360. Let's get our different color out at this point and make a note of why we did that number right there. Why is that? There are 360 degrees in a circle. That's why we're multiplying by 360. And we should know that this is the same as 45%. And this is right here. Let's do that too right now. So a different color. Make a little note of that. This is the percent of total. Let's just do that. Slick, Mr. Wagner. All right, that's the total number right there. 40 is that. And so this, put into a calculator, gives you 162 degrees. 0.175 times 360, that's the same as 17.5%. This is 63 degrees. 0.25, that is 90 degrees. It's 1/4, 1/4 of 360, and 0.125 times 360 is 45 degrees, half of the 90 there, as we should have expected. Okay, so we've got all these values. Now I want to draw my actual circle graph. So what I want you to do, maybe find like a quarter, maybe find a small circle. It could be a little bit bigger circle if you had maybe a small soup can or something like that. You could use that to draw yourself a really nice circle. I want you to find something that you can trace around, or if you have a compass at home, you could use a compass as well. I don't need that up. Here we go. Let's insert a blank page after I ran out of space here. And so find something to make a nice circle with. We'll use, in class we have compasses, so we can use those compasses. I have a compass tool on here. There's my compass tool. So this is pretty cool. I can make this bigger and smaller as I want to, and I'm going to start drawing a circle. So you just draw a circle right underneath what we just had done there. There's my circle. Let me move that back. Oh, let me redraw that circle. I actually wanted to keep that center point right there, so I know exactly where that was, and I'm going to put a dot right where that center point is. Okay, so that's the center of my circle. From there, I'm going to have some segments emanating, coming out of there. And so what is one of those segments? I can start that first one wherever I feel like it. And so let's do that. I'll just make it vertical, straight up from the center to there. Okay, so from there now, I need to use what I have here, use information I got here to make a nice, precise central angle from there. So why don't I start with, I'll just start with 162 here. I'll just go in order. And so coming back to here, I'm going to get out a protractor and I'm going to make it exactly 162 degrees. What I want you to do right now is just watch carefully as I do this. You don't have to do this with a protractor. If you don't have one at home, that's okay. I have some, if you're one of my students, that you can borrow here. But just remember how to use a protractor by watching this. So we are lining up not this point right here, but it needs to line up with the 0. So right where the crosshairs are right here, that needs to line up right with my center of the circle. Okay, and then I should adjust this just a tiny bit there. See if I can do that. Yeah, it's pretty close. I don't know if I can get closer. It seems. There we go. So now this is lined up precisely with 0 degrees right here, and I want to go 162 degrees from that. So here's 10, 20, 30. Notice these values, if I went right here at 162, that would not actually be 162. That would be the 18 degrees part. So how I like to think of it, go to 90 degrees, and then if you're making an angle bigger than 90 degrees, it's going to be the bigger number. If you're making an angle smaller than 90 degrees, you'd have to go this way for the smaller number part. So this is 162 right about there. There we go. 162 right there. And so I would connect that. So you would put, or take a ruler at this point, and I got a ruler tool too. I know, it's pretty cool, pretty fancy, Mr. Wagner. That's pretty nice. Thanks. I know. I didn't make the program though. Thank you, Promethean board makers. You did a good job. You did a real good job. And so from there, connecting the center point to that point right there. See if I can get that tiny bit more lined up. No, I don't want that one. No, I feel like that's pretty good. Okay, that should do it. And so I'm going to now connect that down to there. So I would go all the way down there, but I got to stop where my circle stops. So I would stop right about there. So now that's 162 degrees precisely. We would do the same sort of thing with the other ones. I'm just going to pause the video, fill in the rest there, but we would be measuring 63 degrees, 90 degrees, and 45 degrees. So I'm going to, the next thing I'll do is line up my protractor. I'll show you this just one more time. So I would take that, I would line it up with 0 degrees. So there we go, now it's lined up with 0. I would find the 63 degree measurement. Go away, ruler. Don't want you right now. There we go. And so find 63 degrees. Here's 90. It's going to be less than 90, so we're going to go this way from 90. Here's 63 degrees. I'd make a mark right there. And then take my ruler again, connect that to that point, and then stop it where the circle stops. So I'm going to pause the video, fill in the rest, being sure I'm being precise with that. Okay, so we are good to go here now. And this first one, this is representing, I'm going to get rid of all these tools now. I don't need these up anymore. And so this first part is representing that 162 degree measurement part. That's the number of students that played no sports. It was 18 out of 40, but pie chart wise, that's represented by this 45% of the graph. And so let's take this, and I'm going to have you, you can just use a shading tool here. So let me find a gray instead of what I have here. Alright, so I got gray. I'm going to shade some stuff in with just a really light, you can use a light pencil mark instead. I'm going to leave this one white, just leave it like it is. I'm going to fill this one in. That ain't gray. Thought I picked gray. I changed that. Oh, okay, I got you. Now it's not working again. Okay. I got this. Alright, let's just shade that one in lightly with pencil, whatever you're using there. This other part, let's make that a little darker. So I'm going to use black for that. Shade that in with black. And then this other part, let's use the color, whatever color you're using. and you can shade that in a different color. This is going to help it stand out so we can tell what's what for each part. So right here, this part, we can go back to our normal color now, whatever that was. This was the 162 degree measure, but that's not what it is. It's 45%. That's more what we're interested in. So this was the people, the number. Let's give our graph a label here. Always want to do that with our graphs. This is the number of sports played. Number of sports played. And so this one represented people that played 0 sports. That was 45% of our class, the fake class that I'm using here for that. So this was number of sports played. This was 0 or none, you could say, as well. And so this was 45%. So usually they'll say what it's referring to, and they'll give you the percentage amount as well. You should verify to check and make sure that all the percentages add to 100%. If they add to something more, that's where we see statistical misrepresentations. That's where people are trying to trick us, and if we're smart enough about it, we'll realize what they're trying to do to us, that they're trying to scam us maybe. So one sport, that was 17.5%. That's the part I've done here in gray. That was a 63% part. And it looks like I accidentally did 3 sports next and then 2 sports. Not a big deal, but could potentially be misleading. I didn't mean to be potentially misleading. So this is one sport. This was 17.5%. That was that part. 17.5%. That's a 5. I promise. This part right here, this was not the 2 sports, but this was actually the 3 sports. So it's been drawn already. I'm not going to go back and do that, but generally it would go in order 0, 1, 2, and 3, so I just switch these around. So be careful that you're reading things carefully. If they do something like this where it switches around, I don't feel like I was trying to mislead you, but they just don't happen to go in order. So I think a good thing to bring up right there anyway. So this is not 25%, I'm sorry, so 12.5%. I'm misleading myself now. 2, this is 12.5%, 1/8 of the graph. And then this is 1/4 of the graph, 25%. Okay, so there's a really nice, well done pie chart circle graph, also known as. We'll generally call them circle graphs, but you might hear pie charts as well. Let's move on to a second example. And before I do that, let's just double check this. If you add all these up, do you get 100%? This would be 30, and then this would be this, and this would be 70. So if I add up all 4 of those, yes, I would get 100. Make sure you do that in the end. Make sure that it all adds up to 100%. Okay, example 2. Construct a histogram. What's that, you might ask? Well, that's where we're getting to right here. We'll define it by example rather than giving a formal definition. And a frequency polygon. What is that? Same thing. We're going to look at this example to see what that is. So using the data in the table below. What table? Oh, the one we're about to draw. So here's a new table for us. No, I want to go back to white for that one. Make this darker now. Okay. So here's our new table. We're going to have in just 2 columns in this one. One column will be miles per gallon, mileage, or MPG. So this one will be mileage, otherwise known as MPG, miles per gallon. And over here will be the number of cars. So I'm saying I just took a bunch of random cars and I looked at their miles per gallon, and they fell into this range. So 0 to 9, 10 to 19 miles per gallon. These are class sizes now, so we're taking what we learned in our previous lesson and applying it to this lesson. 30 to 39 and 40 to 49. We'll say that there were 2 cars in this group, maybe a massive souped up Hummer, something like that. Not too many people are going to buy those these days as gas prices continue to rise. 10 here, 9 here, 5 here, and there was one that made it in this class. This car, if you know what this car is, I thought about getting one myself recently, but a Prius. And look what they're trying to do with this ad here. They're just trying to subconsciously make you think like, oh, Prius is really clean, and look at the atmosphere, look at the clouds and the clear day. That's what's going to happen if everybody drives a Prius. You know what? It works for me. If I can get 40 to 49 miles per gallon, you can even get 50 with some Priuses in the city. They're running partially electric. Hopefully they continue to make advances in automobile technology, and hopefully we'll be able to have this be more of a normal thing for cars rather than the exception. But let's check this out, and let's draw a careful graph here. So I want you to get something out, a straight edge, something like that. I want you to draw as careful of a graph as you can with this part. We will, oops, get that vertical line tool. So I want you to draw a vertical line here. Leave a little bit of, I'm going to leave a little bit of space here so I can put different markings down there. We'll be going with a horizontal line here. We'll put some arrows here because this would continue this way, this would continue going this way. And then let's give these a label. So this is going to be kind of tough for me. You know what, I'm going to, don't write this yet, what I'm about to write down. I'm going to rotate this because I can't write on the side very well with this. I can't turn my computer or turn my thing that I'm writing on. So what I'm writing down right now, don't write this where I'm writing this. Wait for it, don't write this down. Wait for it. Please don't write this down yet. It doesn't go over here. Number of cars, okay, frequency. So this will be written down, but I want you to take that and put it down, not there either, almost ready. There we go, put it right there. So turn your paper as necessary. I want you to put that along the y-axis, and then along the x-axis I want you to write miles per gallon. So our frequency will always go on the y-axis parts, and then miles per gallon is going to go down here. In general, what goes down here is either the classes that you have or the data itself instead of the frequency. What are your particular data points that you have in question? And so here I want you to actually make this scale as accurate as you possibly can. I'm going to get out a ruler myself to make this as accurate as I can. Rotate this around, there we go. And I'll go with 1 centimeter. Hey. Finding Nemo, hey. Mine. This is going to be, each centimeter, I'm going to say is 2. So right there is going to be 2. Right there is going to be 4. Right there is 6, 8, and 10. That should do it for me. So let's label those things. On yours, be very, very accurate. I'm going to require you later to be extremely accurate, but if you are just freehanding this, okay, just make sure each space is exactly the same. Here as best as you can, just eyeballing it. Later I'll have you definitely be using a ruler to check that. And so now down here it's a little different. I need to figure out what the midpoint of each part of my class is here. I'm going to be doing that to figure that out. So what is the midpoint of this? From 0 to 9, I would add 0 plus 9 divided by 2. That would be 9 divided by 2, which would be 4.5, 4.5. And so for my spaces here, I'm going to go halfway in between here and here, because I want each class size or each data point in question to have the same width as well. So I'm going to go right here is going to be my first point, and then I'm going to make each one 1 centimeter here. You can use a different width, but the class width from one bar to the next needs to stay the same, needs to stay consistent. So I'm going right here, halfway each centimeter. So this will be 1 centimeter, 1 centimeter, 1 centimeter, and so on. I'm going to put little marks right here because this is where my bars are going to go up from. So I'll put a mark every half centimeter, going up from there, and then the bigger marks are my class marks, my class midpoints instead. So right here, so I got 1, 2, 3, 4. I've got 5 different classes, so I need to add one more midpoint in there. Come on, there you go. And that should do it for me. Okay, I think I'm all set with the ruler at this point. Get rid of those. I don't know how those got there. There we go. And so from here, I want to have some vertical lines here. Right here, what was that midpoint? That was 4.5. So I'm going to label that right here, 4.5. Sometimes they'll be decimals, sometimes they'll be exact numbers, whole numbers. I guess a decimal is an exact number, but they'll be whole numbers. That's a better way to put it. And you'll notice the class width for each one is 10. And so I'm making the jumps 10. And that should also make sense because the halfway between 10 and 19 is 14.5. Halfway between 20 and 29 is 24.5, and so on. This would be 34.5 and 44.5. So squeezing it in there. Maybe I should have made my graph a little bit wider here on the bottom, but that is okay. That's going to work. And then from there, I want to go up vertically as much as I need to. So for 0 to 9, there were 2 that fell into that class size. So I'm going to go up to 2 and then go straight over. So use a straight edge to do this. You could use your ID to do this. If you didn't have a ruler with you, you could use your ID to make a straight line. You could use the side of a book. Just make sure you don't write on the book. Something like that. And so 10 to 19 miles per gallon, there happen to be the most in that category. Those cars, that's a little sad. I'm sorry, it's not the best gas mileage. They might want to think about getting a newer one soon. That's going up. That should be perfectly straight with that. So let me adjust that a little bit. Just come up from there. Okay, that's better, I feel like. I'll just slide that in a little bit. And so from there, we still have 20 and 29. There were 9, that many. So I'm going to go up halfway in between 10 and 8 would be 9. So even though there's no mark there, that's why I'm lining it up with the halfway point, imagining that there was a mark there going straight across there. And then 5, that's going to be, here's 5 right there, go straight across there to that point. And then finally 1, I'd be going straight across there. Should be down just a skosh more. That's pretty good, I think. Okay, and so from there, I'll go down vertically with each one of those to construct the remainder of my histogram. So a histogram is kind of like a special kind of bar graph. You might look at this and say it's a bar graph, and it is, but it's a frequency bar graph. So it has frequency is right there in the picture, right there in the graph. Generally, we would shade this in a little bit, or it would be colored a little bit. So I want to take, I'm going to take gray, you take your pencil and just shade it in a little bit for me. Each one of these, so it stands out a little bit more on the paper. It'll pop out more that way. They can all be the same color, but let's shade all that in. And notice it's kind of got a curve to it as you come down here. We haven't gotten to the frequency polygon yet. We're about to get to that. We're almost there. But I want to make some notes here first before we do that. So let's make this note that these are, that is awful looking. These are the class marks. Class marks are the class midpoints is another way to think of that. So which is the midpoint of each class. And sometimes you might not be using that. You might use the class limits instead. So I want to just make a quick note of that right here. It kind of just depends on what they ask for, or what the situation calls for. We may use class limits. So these 0 values, the lower class limits, 0, 10, 20, 30, 40, you might use the upper class limits, 9, 19, and so on, or whatever your particular class limits are for a particular problem or situation. We might use those instead. So let's put a little circle around that. That is referring to those markings there. And what else? One more marking here. This is the histogram, the bar graph part. So this is the frequency bar graph, more specifically, frequency bar graph. Okay, now within or right on the same picture, rather than do an entirely new example, I'm just going to make using a different color, I'm going to make a frequency polygon. So I want you to put a dot right there, right where the midpoint and the frequency marking converges, right there, midpoint of each bar, the top of each bar, right there and right there. And then I want you to take a ruler and connect those points here to here to here to here. I'll use my straight line tool here and I will connect those points. Do that in different color. Whoa, it's got a weird effect there. Looks like on mine, I don't want that to be in the back, I want that to be in the front. But I think you get the point. That rather than, so I think I can, let me try to figure that out. Might as well. I will have to figure that out later. So I just want you to draw a straight line there, connect those, connect those, connect those, and that's on top of the shading. I have to figure that out later. Frustrating me right now, but sorry, I don't have the time to figure out the rest of that. Okay, so with that, that is the frequency polygon right there. That's all you would need to do. It's basically the same information as a bar graph. You just have the very midpoint of each class, the class marks. You connect all the class marks with how frequent they are, how high it is based on frequency, and you get the frequency polygon. So this is frequency polygon. Using a different color to write this in, and I had meant earlier, let's circle this just so it's a little clearer that the stuff isn't running into each other there. This can go away, and let's make one more note about this frequency polygon. How do you make that? You connect the class marks at the frequency levels with segments. And to me, the word polygon is a little deceiving because the polygon is totally connected, like this part would have to be closed off, but I understand what they're driving at there. So frequency polygon, that is a frequency polygon. And then one more example, I'm going to make one quick note. Rather than do 4 examples, I wanted to trim that down to 3 and just write this down here instead, because I feel like we've talked about the frequency or the bar graphs, the histograms, sorry, enough where you could look at example 5 on these pages 771, 772. So I want you to write this down as a reminder to yourself later. If you need help going from, now we did a data table to the histogram. You might have to go from the histogram and make a data table. So that's why I'm having you write this down. From a histogram or very similarly a frequency polygon. Essentially the same thing, a couple of minor differences there, but they're displaying the same information. So if you need help going from that instead to a table, use that example. That will help you out with that. And so one little note there, and then finally we're going to do example 3. Create a stem and leaf display for the following data. And let's say we have 16 pieces of data here. One is 59, one's 73, got a 63, got a 100, 92, 57, 94, 66, 79, 73, 67, 60, 79, again, 51, 97, and 78. And we're going to say that these are some test scores from a particular class. They are made up. This is not a real set of data. Just so nobody's worried that they got a 51 on a test or something like that. But let's say this was the case. What would a stem and leaf display look like? It's basically a histogram, but the data is right there in the table. Like if you look here at the histogram, okay, there were 2 people that were in this 0 to 9 class here, with the class mark being halfway in between there. But what were those 2 specifically? Was it like, was it 5 miles a gallon? Was it 7 miles a gallon? From this, we can't tell that information. That's the nice thing about a stem and leaf display. You have the frequency, you have it visually displayed, but you also know exactly what the numbers, the particular values were as well. And so I'm going to have, this is going to be my stem part. If you think of a plant, that's why they named it this. This is going to be the part where things are coming out of, where the leaves are coming out of. So this is the stem part. This is the, for us it's going to be the tens place. And so, except for when we get to 100, then it's kind of the tens and hundreds place. So 5, 6, 7, 8, 9, and 10. So each one of our values is branching off of either 50 something, 60 something, 70 something, 80 something, 90 something, or 100 and something. That's my stem. And with that, let's use normal color for this. There we go. So I want you to draw in a nice solid straight line, vertical line like that. And let's make a little note of this. We'll do this in a different color now. This is my stem part. What's my stem part? Is it just the 5? No, it's the whole thing. So let's circle the whole thing in a different color. That's the stem of my stem and leaf display. Now for the leaves, now the parts that are branching off of each stem. I'm going to put these in order. You wouldn't necessarily have to put them in order, in numeric order. You just have to make sure you get all the 50s, you get all the 60s, and so on. But this list is small enough where it's not going to be too cumbersome. If you wanted to put them in order and you had a bigger list, you should probably make the data table, rewrite the data table, put them in order first, and then go there to your stem and leaf display. But I noticed 51, that's the lowest score, so I'm going to put a 5, 1. That's representing 51. I'll cross them off as I go. 51, 57, and notice I'm going to leave gaps in between each part. I want to keep even spacing as much as I can, so I'm going to show that, I'll even do this in yellow. You don't have to draw anything here that I'm doing here, but this is just to show that I'm trying to keep even spacing as much as possible as I go about this. That way the visual effect of the stem and leaf display is like it should be, where it's showing not only a histogram type of bar graph, if you kind of look at it on a side, but also it's showing the individual values. So 51, 57, and 59. Those are my 3 and only 3 50 values. 60 values, I have 63, it looks like is the first one. No, 60 is the first one. 60 and then 63 right there. And then I look around, 66 comes next, and 67. And again, yes, I am doing this in order, but they wouldn't have to be in order unless you were told they had to be. 73 comes next. There are 2 of those, so I'm going to put 3 down twice, here and here, and get rid of both of those. And then 78's right there, and I've got 2 79's as well, so I'm going to put 2 9's here and here. So notice there are 3 values in the 50s. That's why this goes up 1, 2, 3, and you can also tell exactly what they are. It's 51, 57, and 59, and so on. There's 4 values in the 60s, 5 in the 70s. There aren't any in the 80s, so I left that, and I'm going to leave that blank. There's nothing here. I don't put a 0 here because that would be 80. There's no 80 value up here. There's just nothing for the 8s. So I'm going to leave that blank. I feel like I should insert the 8 here though, because then you know that there wasn't anything for the 8s and it wasn't just magically jumping to a 9. So 9, what do we have for 9? We've got 92, got 94, and we've got 97. And then finally for the 100, we have the 1 and 0 followed by another 0 would make 100. So there is that one. These are called, this whole part here, let's circle this whole part here in the different color. This part here is called the leaves. So notice the stem. These things are branching off of the stem, just like leaves in a plant branch off of the stems. These are the leaves right here, this part of that. And let's write one more thing here. This row, we'll just do this one row. This row represents, this was 51, this was 57, and this was 59. So that's what that row represented right there. This row, I'm not going to write this in, but this would be 60, 63, 66, 67, here 73, 73, 78, 79, 79, nothing for 80s, 92, 94, 97, and finally 100. That'll do it for us. Hope that went well for you. Go back and rewind and rewatch as needed, and let me know in class if you had any questions. Have a good one, everybody.